Hi everyone. Today let's talk about section 9.3, spanning trees. Here is the definition. A tree T is a spanning tree of a graph G if T is a subgraph of G that contains all of the vertices of G. So we need T to be a subgraph to contain all of the vertices of G, and also we need it to be connected and acyclic. So remember, a tree must be connected and it has no cycles, okay? Alright, so example, a graph may have several spanning trees. The spanning trees are shown in black. So you can see here, here is one example, okay? So we can have this one. Let me just highlight it. You can see this spanning tree, it contains all the vertices of the graph. Of course, it does not contain all the edges of the graph. Otherwise, it's not a tree. And here we have another spanning tree. Okay, so you can see the same graph. We can have several spanning trees. Okay, so next theorem. A graph G has a spanning tree if and only if it is connected. Okay, so as long as the graph is connected, then we can find a spanning tree, which contains all the vertices of G. So in this session, we will introduce two methods of finding the spanning trees. First method is called a breadth first. Second method is called depth first. Okay, so the idea of breadth first search is to process all the vertices on a given level before moving to the next higher level. Okay, so here are the steps. So here I write down all the notes for you. So let's go over together. Step 1, we select an ordering. Let's say in here we have the vertices A, B, C, D, E, F, G, H. Let's pick this natural order. So I hope that when you do your homework and or exam problems, if there is a natural order, pick that natural order. So it's easier for me to grade. Of course, if you fix another order, you will have a different spanning trees. Okay? So pick the natural order of the vertices. And then next, let's select the first vertex A and label it as the root. Okay? Then we let T be the set consist of the single vertex A and no edges. Okay? Then T is like our tree. So every step we're gonna add some edges and some vertices in the tree. Okay? And then finally we will get a spanning tree. So let me draw a picture here so you can see a difference. So we have A. This is like level 0, right? Next, we add to T or edges A, X, and the vertices on which they are incident to these edges. For X equals B to H, so we follow the ordering. So A, B, C, D, E, F, G, H, right? So that's why we check the vertices from B to H. And make sure that we do not produce a cycle when we add the edge to T. So let's look at this picture. So we have B, okay, it's adjacent to A. So we add AB. And we have C adjacent to A, so we add that. And then we also have G adjacent to A, so we add that. So in this example, we add AB, AC, and AG. Okay, so if I draw this picture, you can see this is B, this is C, this is G. And they are level 1. So far, so good? So we repeat this procedure with the vertices on level 1 by examining each in the order of A, B, C, D, E, H. So let's look at B first. B, we see is adjacent to D, so we can draw D right here. Okay, and B is then adjacent to also G and A, but we already have A and G, so we don't need to include those edges. And then let's look at C. C is adjacent to D, but D already included. And then so A, B, C, D, E, then E. Okay, so we have C, E. So far, so good, everybody? Okay, and next, G. G is adjacent to E, but we already have E, so that's why we don't need to draw anything next to the E, G, okay? So that's why we put none right here. Okay, so this is level 2. We repeat this procedure, follow the ordering. So D comes first. So let's look at D. You see, D is adjacent to F, so that's why we have the F here. Okay, and E is also adjacent to G and F, but we already have those two vertices in our tree T, so we don't need to include that. So that's why D, we include the F, the edge, E, none. Okay, so here we get level 2, and that's level 3. Okay, so finally you look at the F. F is adjacent to H, so that's why we have H here, and H will give us level 4. So far so good. So you can see repeat this procedure with the vertices on level 3. Then we get F, the edge, FH. Then we obtain our trees. Okay, yes, since no edge can be added to the single vertex H on the level 4, the procedure ends. So you can see that is the tree, and the height equals 4. We have 4 levels. So far so good, everybody. So this is the breadth first method. We fix the ordering, and then we go to the vertices on each level, follow the order, and then we find the vertices that are adjacent to that level, the vertices of that level, and then we go to more and more levels. Okay. Next method is the depth first search. So depth first search proceeds to successive levels in the tree at the earliest possible opportunities. So first, we still need to select an ordering. Let's pick the natural order A, B, C, D, E, F, G, H of the vertices of G. Okay, next we select the first vertex A and label it the root. Okay, so we have 8 right here. Okay, next, let T consist of the single vertex A and no edge. So T is like the tree, okay? And when we go more and more steps, we add more edges and vertices to the T. So eventually we'll get a spanning tree. Okay, so the next step, we add the edge AX with minimal ordering X to our tree. So in this case, you see A is adjacent to B, C, G, and B has the minimum order. So that's why we add this edge. Okay, and then remember for our breadth first search, we also need to add the edge AC and AG for each level. No, in this depth first methods, we only add one edge at a time for each level. Okay, so we add the edge AB, and then now we repeat this procedure with the vertex B. Okay, so now you can see B is adjacent to D and G, but D comes first, so we add BD. Okay, and then we look at so BD, and then D is adjacent to CF, but C comes first, so we add DC. Okay, C is then adjacent to ADE, but we already have A and D, so now we add CE. See, each level we only add one edge. Let me put it here. So each level we only add one edge. Okay. And then we continue. E is adjacent to G and F, but follow the ordering. So F comes first, so we add the F. Okay, next F is adjacent to D and H, but we already have D, so we add the H. So E and then F and then H. So far, so good. So you see, every level we just add one edge and vertex. Notice that when we get to H, it terminates. But we still have the G that we haven't added to the tree. So what do we do next? We backtrack to the parents of F and try to add an edge of the form fx. So, but here you can see F is not connected to G, so we cannot add an edge of the form fx. Then backtrack to the parent E of F. So this time we can see we can succeed in adding the edge EG. So let me change a different color here. Okay, so this time we can add the EG. So EG is right here. Okay, so remember, once we terminate, we backtrack to the parent. We don't start at the beginning. You don't start with A and say, oh, EG. No, we backtrack. Okay, so let me put it down. Once terminates, we backtrack to the parent. Okay, or the parent and then another parent until we find an edge to connect that remaining vertices. So far, so good. Okay. And then we are done. So what can you see about this tree? You see is it really gives us the highest tree. So this method gives us the highest trees. Okay, so depth first search give us the highest. Usually, okay, so usually that first search give us the highest tree compared to the breadth first search. Okay. All right. Okay, so let's continue. What's the height in this case? So this is level 0, 1, 2, 3, 4, 5, 6. So the height here is 6. So far, so good, everybody? Okay. Let's continue. Why do I say usually? Because I'm comparing the two methods, breadth first and depth first. Depth first search gives us the highest tree, but if you use the depth first search, if you pick a different ordering, maybe the height will be different. Okay, so if you want to find the highest tree, you also need to like try different ordering until you actually find the highest one. Okay, so let's look at the following example. We want to use the breadth first and depth first method to find the spanning trees for the graph. Okay, so far so good, everybody? Let's see. Let's change our color, orange first. Okay. And let's see. Okay, so breadth first. All right, so let me draw the picture here. So we have A. Okay, so let's fix the order. let's use the natural order A, B, C, D, E, F, G. Okay, let's use the natural order. Okay, then we start with A. Okay, then we look at the vertices that are adjacent to A. Then we have what? A, E, F, and G. That is the first step. Okay, and that will give us the first level. And then next level, we're gonna do look at E, right? E is adjacent to C and D, so we include that. So we have C and D. Okay, this is for the E. How about F? F is adjacent to B, right? Oh, okay. So let me change the color so you can see the difference. Okay, so it's still in the same level. F is adjacent to B. So far, so good. And then we already cover all the vertices. So this is the spanning tree that we're looking for. So far, so good, everybody. If you want to redraw this picture to make it as like a rooted tree, we can write like the A here, and then we have E, F, G, and E we have C and D, F we have B. So this is the rooted G. So far so good, everybody. And this is level 0, this is level 1, this is level 2. So that's why we have the height equals 2 in this case. So far so good. Okay, next let's look at the depth first. So depth first, we also start with A, and then well, A is adjacent to E, F, G, so we only pick one edge, which is the minimum order. Well, that's the E, right? And then E is adjacent to C and D, so we C comes first, right? So we have EC, and then C is adjacent to B, G. Okay, so that's why we connect to the B. And then B is adjacent to F, right? C, I already have it. So F, let me change a different color so you can see F. So this is F. And then F is adjacent to D, so we have the D. Finally, D is adjacent to E, F, G, but we already have E and F. Oh, so this is G. So you can see one path. In this case, we have one path goes through all the vertices in this case. Okay. So far, so good, everybody. Okay. And what is the level of it? Because we have one path that contains all the vertices in this case. So let's count. 1, 2, 3, 4, 5, 6. So height is 6. Okay. So if for a fixed ordering, if we compare the height of a breadth first and the depth first method, we know the depth first method will give us the higher tree. So far, so good, everybody. Okay, so if we go back to, let's see. If we go back to our example, so remember we talk about the spanning tree. So those are the two trees. Actually, the first one is using the breadth first method, and the second one is using the depth first method. Okay, so this is the breadth first method, and this one is the depth first. Okay, so you can continue to do your homework, and we have a lot of exercise. You can use both methods to find different spanning trees. Alright, so that is session 9.3. Have a nice day. Bye.